So remember that for a balanced chemical reaction, when we look at this chemical reaction, it's actually telling us that 1 mole of CH4 is reacting with 2 moles of oxygen to produce 1 mole of carbon dioxide and 2 moles of water. Now, since we have the delta H at the end here, it's also telling us that 890 kilojoules of energy are released when we have that many moles reacting and that many moles being produced. So for the first problem, how many kilojoules of heat is released when 1 mole of CH4 is burned? Well, because it says in the balanced equation 1 mole of CH4, then that means that we're going to have 890 kilojoules of energy being released. Now, letter B and letter C get a little bit more complicated. Because letter B wants to know, well, how many kilojoules of energy is released, heat energy is released when 2 moles of CH4 are burned. So that means that we have twice as much. So we can use the conversion factor that 1 mole is 890 kilojoules being released, and we can multiply that conversion factor by 2 moles. And then finally, letter C is even more complicated. We need to find out how many moles are in 13 grams of CH4. So that means that we're going to need to find out the molar mass of CH4. So we look on our periodic table, we find the molar mass of CH4. So we're going to take 13 grams and we're going to multiply it by the conversion factor of 1 mole equals the molar mass of CH4. Now that we know how many moles of CH4 we have, we can use the relationship from our balanced equation that says that for every 1 mole of CH4, we are going to release 890 kilojoules. And then we can figure out how many kilojoules of heat energy are released when there are 13 grams of CH4 being burned. So check out my work for all of these problems. Make sure that you understand them so that you can complete them on your own.